like, they say there is some command called pause command, right? So how is it like, actually different from a stop command? So it is used to like, update some configuration, but we can update the configuration use it after stopping the containers also, right?
Yeah, so what happens is when you stop the container, your container is down. Okay, there's a downtime associated with your container. Okay, any applications that you're running inside that container, you won't be able to access it. Now with
Okay.
your pause, what you can do is your it won't update. The application would still be there. The application would still be running, but it won't update any logs. It won't update any system files or anything.
Okay. Basically, the applications like, associated with the containers will be accessible.
Yeah,
Okay, got it. That's it, Ravi.
cool. All right. So just a quick recap of what we did yesterday. So yesterday we've looked at Docker images. We looked at the various commands that we have as part of your Docker images. Then we looked at your Docker containers. So we looked at what your Docker containers are, the introduction basically, and then we also looked at the various commands that we have as part of your Docker containers, right? So we looked at a variety of commands: how to run the containers, how to stop the containers, how to connect to the container, interacting with the containers, and all those things. So we looked at a variety of commands. The next thing that we are going to look at is your Docker file. Now, Docker file, now that's a very important section we have in your Docker, right? So at any point when you say Docker, that means you're telling that you know how to build your custom images, right? And that is where this Docker file is important, right? So at any point you want to, so until now, we have been using the images which are already available, right? So what we have been doing is uh, we are going to the we go to the hub.docker.com, we search for the image that we want, and then we are using that image. So we are simply reusing the image which is already there, right? But in most of the cases when you're working at an organization level, what happens is you won't be using these images. Why? Because these are public images, anyone can use them. At an organization level, you'll always create your own private images, which only you can use, only within your team can use it. And that's where we have the next concept, which is your Docker file. So whenever you want to build your own custom images, we make use of your Docker file. So what is your Docker file? Your Docker file is simply a text file, right? Which has all the instructions to build your custom image. All right. So remember the layers that we had discussed about. So all that information will be available within your Docker file. And once you're done providing all those instructions, you can use this Docker image build command, which will start executing all those instructions one by one and create the custom image for you, right? So your Docker file, so at any point you want to build your own custom images, we make use of your Docker file. Okay, so your Docker file is simply a text file, okay, which contains all the necessary instructions. So Docker can help you build your own custom images by reading instructions from a Docker file. So at any point when someone comes and tells you like, hey, can you build a custom image for this, so they're basically telling you to have a Docker file, have the instructions in the Docker file, and then create an image out of it, right? So your Docker file, it is simply a text document, and this contains all the commands a user could call on the command line to assemble an image. So basically, all the instructions that you want inside the image, all that will be available within this Docker file. So once you're done writing the Docker file, you can use the build command to create an automated build that executes several command line instructions in succession. So we run this Docker build command, and what that will do is it will start reading all the instructions we have in the Docker file, and it will start creating the custom image for us. So generally, when we talk about your Docker file, it consists of two blocks. One is your comment, and the other is your command plus argument. So comment, you'll always see this hash symbol. Okay, so something like, let's say, comment 1, comment 2, comment 3. So this will be your comment, and then you'll have your commands plus arguments. All of your commands will be in the uppercase. Just I'll show an example for this, and then followed by the arguments as to what you want to do, like install something, or copy some files, or start some service. All that will be in your arguments. So generally, when we talk about your Docker file, it can consist of your comments and your commands plus arguments. Now, to start with this, you will need to create a file with the name Docker file. So literally, you will have to create a file with the name Docker file, because when you're building the image, Docker will look for a file with that name only. Okay, you cannot use any other name. You have to create a file with the name Docker file. Okay, so that's one thing you'll have to remember. Sorry, give me a moment. This IP address.
Rabi, one question. So, like, when we run, like, Docker PS command, so it shows that, which container is running and then which is stopped. But that what is that exited things, like, it shows exited means stopped, right?
Correct. So only if the status shows up. Okay.
Okay.
So only if it shows the status as up, that means your container is running. Okay.
Okay.
Any state other than this, your container is not running.
Okay.
Okay. So your Docker PS will only show the containers which are running. Okay. It won't show you the stopped containers or the killed containers. Any containers which is not in the up status, your Docker
Okay.
PS will not show it. So for this, you'll have to use this -a flag, and this one will show you all the containers irrespective of the status. So now here, if you see this exited, that means this container is not running.
Okay. So what is that 137, like, right next to that exited?
That's your exit code.
Okay. Okay.
Okay, so 137 generally this, I mean, anything that you see within this brackets, that's an exit code. Now in this case, your 137 indicates that this container was forcefully killed.
Okay.
Okay, so you can have, if you see exit code 0, that means your container was gracefully killed. So gracefully means,
It just
all the
stopped.
processes, correct. So all the processes stopped first, and then the container was killed.
Okay.
And if you see 137, that means all the processes were forcefully killed and the container was stopped.
Okay, got it. Thank
So
you.
it's simply a exit code. All right. So yeah, to begin with this, you will need to create a file with the name Docker file. It can be, no, it's not case sensitive, so you can use uppercase, lowercase, whatever you want. But you have to make sure you are creating a file with this name only. You cannot use any other name, because when you run this docker build command, Docker will look for a file with this name only. And if it does not find this file, your build step will fail. So the first thing you'll have to do is you'll have to create a file with the name Docker file. Okay. And then you can start adding the instructions. So the first instruction we are going to look at is a from instruction. Now, generally, when we are creating your custom images, we always make use of a base image. So what is a base image? Base image is a plain image which does not have anything. For example, let's say you want to build a house. Now, to build a house, we have an empty site, right? Empty, let's say a 30-40 site, which does not have anything. So it's a base now that we are using. It does not have anything. And then on top of that, we start constructing our house the way we want it. We start doing all the modifications and everything. Likewise, whenever you're building a custom image, we make use of a base image which does not have anything. It's a plain image. Okay, it does not have anything that we want. So we use that base image and then we start doing the modifications on top of that. So to specify the base image, we can make use of your from instruction. So what is the base image that you want to use? That instruction we can specify by making use of this from instruction. So initializes a new build stage and sets the base image for subsequent instruction. So to set the base image, we can make use of this from instruction. So as such, a valid Docker file must start with the from instruction. And the image can be any valid image, and from can appear multiple times within a single Docker file. So let's say in our case, I want to use Ubuntu. You can use any image you want. That's totally up to you. Okay, so let's say, let me see if I have an example. Um, okay, let me. Let's use Ubuntu as our base image. You can use anything: Alpine, Nginx, BusyBox, Ubuntu, Python. Any of these you want, you can use as your base image. In our case, we are going with Ubuntu, which is a plain image which does not have anything. So we will go to this Docker file, and the first thing we are going to use is your from. Now, this from is your command. So all of your commands will be in the uppercase. Followed by that will be your arguments. So in our case, I want to use Ubuntu. So Ubuntu here becomes my base image. Now all the subsequent instructions that I will give will get executed on this base image. Does this make sense?
Yes, Ravi.
Okay. The next instruction we have is your ARG instruction. Now, ARG is the only instruction that can come before the from instruction. So this is the only instruction that may precede the from in the Docker file. And from instruction supports variables. So ARG is used to set your variables, right? So the from instruction, it supports the variables that are declared by any ARG instruction that occurs before the first from. An ARG declared before a from instruction is outside of the build stage, so it cannot be used in any instruction after a from. So this ARG, if it is preceding a from instruction, you can use it only with the subsequent from instruction, nowhere else. Okay, so something like this. So let's say here we are defining a variable. So that's the only instruction that you can pass before the from instruction. So ARG and then your variable name and the value that you want. So let's say version is equals to latest. So this becomes my variable name and this becomes my value. And then you can call this in your subsequent from instruction. So something like this will be the format. So dollar and then curly braces and then the variable. And so this is how we call the variables in your Docker file. So what will happen is this will replace it with the actual value. Okay, so it is simply to set your variables and then you can call those variables in the subsequent from instruction. The next instruction we have is your label instruction. A label instruction can be used to define any additional information like author name, who created this Docker file, description, what is the purpose of this, when this was created, what is the version of it. All that additional information you can provide by making use of your label instruction. So a label, it's a key value pair, and this adds the metadata to an image. So it is simply your additional instructions. Any additional instructions you want to pass, you can pass something like this. And you can pass the instructions multiple times if you want. In a Docker file, if you want to pass an instructions multiple times, that is also possible. You can do that. So here, let's say, for example, we will say label and then something like, let's say I will set the author, right? So this becomes, all this becomes your additional information. So again, let's say label and then let's call this as version 1.0. Then let's say label description, let's say this is an example for custom image. So like this, any additional metadata you want to pass, you can pass that using the label instruction. The next instruction we have is a run instruction. Now, if you want to execute any commands on top of this base image, when I say execute any commands, create some files, create some folders, create a user, install some packages, start some services, any instructions you want to run, you can do that by making use of your run instruction. So this instruction will execute the commands in a new layer on top of the current image. Okay, so on top of the current image, and then commit the results. So the resulting committed image will be used for the next step in the Docker file, something like this. Again, you can pass the instructions multiple times. So let's say we'll say run and I'll say apt update. So what this will do is this will go ahead and update the image. Then let's say apt install git. Now it's not necessary that you have to pass this. I mean, if you have multiple commands, it's not necessary to have these run instructions multiple times. You can make use of this ampersand, which is similar as and. So this command and the next command. For that, we can pass it in the same line, or if you want it in separate lines, you can do that also. That's totally up to you. So let's say we will say apt install default hyphen jdk hyphen y. Likewise, let's say ampersand, and then apt install Apache 2, like this. You can pass any instructions that you want to execute using this run instructions. Questions?
Ravi.
Okay. Next, we have the CMD instruction. Now, a very common interview question you can expect is What is the difference between run and CMD? Now, both are used to execute the commands. Run executes the command when building the image. CMD executes the command when creating new container. Okay, so it's a two ways to run your commands. All right, so whenever you use the run, that means you're telling that to execute the instructions when you're building the image. And whenever you use CMD, that means you're telling that execute the commands only when I'm starting the container. So it will be like a trigger. Does this make sense?
Basically, in the Docker file which we are creating, like so inside that only are we adding some comments to create the new container. Like once we run that image, so it automatically creates the container. Is it?
No. We are just passing some commands. That's it. Now, whenever I use CMD, my Docker will understand that, okay, these instructions should not be executed now. These instructions should be executed only when I start a container. That's all. So
Okay.
until I don't use the Docker run command, the CMD instructions will not get executed.
Okay, got it.
So this one will get executed when I use this Docker build command. And this one gets executed when I use the Docker run command.
Okay.
So use case can be when you want to start some service or start some process, you can make use of your CMD instruction. So this is similar to the run command and is executed and this is used to execute the commands on the container. So the difference is that the run command gets executed when you build the image and CMD gets executed when you run that image as a container. So until you don't start a container using that image, your CMD instructions will not get executed. So this instruction will get executed when you run the container after building the image. So, like starting some processes or anything, for that you can make use of this CMD instruction. So here I can pass your CMD. So something like, let's say for example, you have your Docker. So Docker is a client server architecture, right? So you want to start the Docker service, or you want to start the Apache service, or any service generally you want to start. You can make use of your CMD instruction for that. Does that make sense?
Got it, Ravi.
So let me show this. So let's say look for Apache. Okay, so let's look at this. Just give me 1 minute. I'm looking for something.
So we can only use hub.docker.com as like cloud repository, is it? Like, is there any other cloud registry where we can use?
Yeah, if you're on AWS, you can use this service called ECR. which is your Elastic Container Registry. You can use that to store your images. Then, so the respective cloud, they have their own registry. So AWS
Okay.
has its own registry, Azure has its own registry, Google has its own registry. Other than this, you can use Nexus, JFrog. Docker Hub is something we can use at an organization level. Like in our project, at least we're using it. Docker Hub is what we're utilizing. So,
Okay.
but if you're on cloud, then it's much easier to leverage the ECR service itself to store your images. Because what happens is with your Docker Hub, you need to purchase licenses. Like if you want to share, you need to purchase licenses,
That
and
means when you are pushing the the image.
yeah, or someone if you want to collaborate with other people, you need to have that license.
Okay.
So yeah, I mean there are many criteria that you'll have to look into before you can decide which one you want to use. What is this? Okay. Let's look at this. Okay. 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 So what's this? So this will be the instruction for my starting the Apache server. Okay, so let me explain this. Okay. So this is where my Apache 2 binary files are present. I'm telling it to start that process in the detached mode, in the foreground mode. So, with your Docker file, we don't have something like, service Apache to start. That will not work. Okay, so we are directly going to the binary files and then we are starting that service like this. So generally the use case of your CMD is to start some service or start some process. That is basically only when I'm starting the container, you start the process. If not, don't start the process. That's the whole point of your CMD instruction. That is it. Does that make sense?
Yeah, understood. So binaries basically is one type of library, right? One type of the package.
Correct.
Okay.
So binaries are basically your it's basically your instructions that your machine can understand.
Okay.
The next instruction you can have is your expose. Now, expose can be used to specify the port number. If you have any application that runs on certain port number, you can specify the port number by making use of this expose instruction. So the expose instruction informs Docker that the container listens on a specific network port at runtime. So if you recall, yesterday I was using this one, right? So if you want to specify what port number you want to use, we make use of your expose instruction for that. So you can specify whether the port listens on TCP or UDP, and the default is TCP if the protocol is not specified. And to publish the port when running the container, we use the -p flag. So, to publish the port, we'll be using this -p. Okay, so if you want to specify on what port number you want the application to run, for that we make use of your expose instruction. So now depending on the application that you're running here, you will be specifying the port number. Like if it's a Java application, you'll use 8080. If it's a Python application, you'll use 3000. If it's a database, you'll use the respective port number. In our case, we're using Apache 2, so it will be port 80, which will be HTTP. And if you want HTTPS, we will be using 443. Does that make sense?
So in AWS, like, when we used to give access to the inbound rules and outbound rules, so we used to use that port number, right? It is like the same port number you're using here, right?
Correct, the same port number. So these are all your standard port numbers.
Okay.
These are common across anywhere you go. So whether you're on Azure or GCP or AWS or physical machines, these are standard port numbers. So 22, that's standard for SSH. 80, that's standard for HTTP. 443, that's standard for HTTPS. No matter where you're using it, that's the port number. That's the standard port number. Okay. Any other questions?
No, Ravi.
Okay, I'll stop here because Sedu also dropped. So tomorrow I'll show you. So we'll keep this here. Tomorrow I'll show you how you can build that. There are more instructions, but we will take it step by step. So tomorrow, whatever the instructions we have in this Docker file, I'll show you how you can build an image out of this and how that image looks like. I will show that. And then there are more instructions which we will discuss next week. Sorry, Monday. Right, so we will discuss about all these instructions on Monday. So next week, I'm targeting next week to finish off with your Docker, and if that completes, we will start off with your Kubernetes as well.
Okay, Ravi. Ravi, like one doubt, like yesterday you executed like Docker commit command. So there, like you downloaded the Git and then you downloaded the Java SDK file and all. So after that, like you started executing that commit command. So will it save on the container or will it save on the like image?
So this will create a new image for us. When you do that commit, you are basically creating a new image. Now, whatever we are doing here, right? The same thing we can connect to a container. We can manually run this and create an image out of it. But generally, this is the practice that we follow.
Okay, got it, Ravi.
Cool. So I'll see you guys on Monday then. And try to start on time because we're hardly doing 30-40 minutes, which is not good. So from next week, I'll try to have that at least 50-55 minutes of session so that we can cover more topics as well. Okay.
Sure, Ravi. Thank you.
Thank you, Professor. I'll see you. Yeah.